In this video, we're going to take a quick look at the applications of limiting and excess reactants. So what's the point of all of this in these calculations of limiting and excess reactants? So in reality, most reactions that you do are going to have some kind of limiting reactant and therefore an excess reactant. You'll run out of one before the other. And why do we have that? Well, one reason you might want to do that in the industry is to reduce cost for manufacturing. So, for example, let's say you want to make this compound called cisplatin, which is used to treat certain type of cancers. Notice that there's platinum in it. And so when you do a chemical reaction to produce cisplatin, your limiting reactant is going to be the most expensive one, which is platinum. So that way you're not wasting your one of excess platinum left over at the end. You're just going to use up all the platinum and then you'll have the cheaper stuff that's left over. And then if you want, you can add more platinum as you need to. So that could be one reason why you might have a limiting reactant, and you might want to choose that to be your platinum. You might want to reduce the environmental impact. So let's say you want to burn fuel or do combustion reactions. Rather than have all the soot produced and carbon monoxide, maybe you want to do excess oxygen so you can have plenty of oxygen for the combustion reaction to go through. And that kind of applies to fuel efficiency as well. You want to do more complete combustion. So you want to make sure you have excess oxygen, a sufficient supply of oxygen so it's not incomplete and you have more energy released and it's a nice clean burn as opposed to that incomplete combustion happening. Maybe also you might use them for environmental cleanup. So let's say there's an acid spill and you want to neutralize an acid spill, you might want to use excess sodium chloride, because if you don't use enough, sodium bicarbonate. Sodium bicarbonate's a base. If you don't use enough of that sodium bicarbonate, the sodium bicarbonate will run out and you'll still have acid left over. You don't want that to be your excess in the reaction. So use excess sodium bicarbonate to neutralize an acid spill. And you'll have leftover sodium bicarbonate, but that's basically baking soda. Everything else reacted, your acid should be gone, and then it's a little bit safer to clean up and to handle that region afterwards. So these are just a few examples of applications of limiting and excess reactants that you might see in the real world. Whenever we do chemistry in the lab, we're going to have some kind of excess, some kind of limiting. It won't be an exact perfect match every single time. So it's important to know how to calculate excess limiting reactants, especially when we want to predict products in many different types of fields and lab and practical lab situations. So in your handout, you can go ahead and fill out the notes for reducing for applications. So, for example, here we know that we saw the example of cisplatin, which is to treat cancer, and we saw that the limiting reactant, the LR, is platinum because B/C means because it is the most expensive ingredient or reactant there. So we don't want to waste it, and we're going to use that as a limiting reactant instead. And then, of course, you can read through the other applications there. If you can think of others, provide some more. If you know examples that you might have learned somewhere else or you can think of off the top of your head, make sure you add those and share them with others, and make sure you research that they're actually valid examples. But it would be great to see if you can provide any of your own.